Our aim is to create a boost converter that delivers a 24 DC output from a 12 volt DC input by using a feedback mechanism. In order to achieve this, we have utilized three systems linked together. The first system is the boost converter main circuit that increases the voltage output. It utilizes two switches, the first being the MOSFET that is controllable within this whole circuit, and the second switch will be the diode. These two switches activate alternatively in order to store energy into an inductor and then discharge it to increase the voltage delivered to the load. The second system is the 555 timer system that determines the duty cycle of switching by directly controlling the time which the MOSFET, or in other words switch 1, is active. It achieves this by receiving the output of the error amplification system directed into its reset terminal and thus switching its own time cycle accordingly. The clocking rate of the timer will then affect the active time of the MOSFET. And finally, our third system is the error amplification system. It is essentially an op-amp with a series of resistors that effectively act as a voltage comparator. The output of this system is dependent on the difference between the desired output and the current output. This system output is then sent to the 555 timer, which will alter its cycle according to the voltage given. As the output reaches the target value, the 555 will slowly settle into a set duty ratio for the final output voltage to be delivered. As we can see, the system was meant to convert a 12 volt input to a 24 volt output. We have connected a multimeter to examine the output voltage, and as you can see, it is oscillating within an acceptable range. With this setup, we are able to light up to 14 LEDs when they are connected in parallel to a 1200 ohm resistor. This setup is also theoretically able to boost above 24 volts, thus lighting up a few more LEDs. This setup, we are only able to light up to 14 out of 16 given LEDs. This is because that for each LED there is a voltage drop of approximately 1.5 volts. The remaining voltage drop is across the current limiting resistor over here. And in the case of the LEDs given, each of them requires a safe current of about 20 milliamperes.